Hello, Karnaugh's map plotting. So, how to plot a Boolean sum of product expression in a K-map? A Boolean expression in canonical, which is the expanded or the long form, can be plotted in a K-map. Now, for the given min terms, the truth value is 1, and for the ones which are not there, the value is 0. Now look at this example. The example reads G1, which is the Boolean expression, A bar dot B bar dot C bar. Now this is in term number 0. Then is A bar plus B, no, A bar dot B dot C. Now A bar dot B dot C is term number 3. A dot B bar dot C bar is term number 4, A dot B bar dot C is term number 5, and ABC is term number 7. Now look into the K map. The K map where the terms are shown, and then we come to the corresponding K map, which looks like this, where whichever was present as term is plotted as 1, and whichever were not present are plotted as 0. Then now look at this G2. Pause the video and look at the terms. The terms are A bar dot B bar dot C bar dot D plus A bar dot B bar dot C dot D plus A dot B bar dot C bar dot D bar plus A dot B bar dot C bar dot D plus A dot B dot C dot D bar plus A dot B dot C dot D. Oof. Now you look at the truth table. You will be able to identify whichever terms are there. Those will be plotted as 1 in the K map. Now look at this carefully, and now look at this carefully. You will be able to identify that those terms. You may pause the video or go back a bit, and then you can see that okay, this is how the plotting is done. And then the next thing to be done is reducing a Boolean expression using Karnaugh's map. Now, in order to reduce an expression, we need to know about few important terms. There are something called groups in a K-map, and the groups can be a pair. A pair is formed when two terms are placed either sideways or horizontally. Then, in a group which is a pair, one variable gets removed, the one which is changing state. Now, it is also possible for a K map not to have any pair, it can have single one also. Now, keeping this theory in mind, we'll go to an example. Look at this example, it clearly mentions which one is a proper group and which one is not a group. You may pause the video and see that it is not a group, it is a group, it is diagonally not a group, and then vertically and horizontally here we have two group, two pairs. This one also shows us a K-map of two variables, though it's very minimal. And here we have a three variable K-map. This K-map, only the K-map shows that no, you cannot form a group with three ones. Well, more examples are going to come, but before that, let us also learn about quad. A quad merges four terms into one term and removes two variables which change state. Now look at this. If you look into the first example, you will see that there are four ones which are placed side by side. A quad can also be formed if the ones are placed in a square form, like the first two and the next two in the next line. Now you can pause the video and look at it carefully. Then you will realize, okay, here we have got one quad present. The second one is a wrong example. Here again you can see that there is a quad in which the first example is correct, whether four of them are together. But the second one is not correct because there is zero creeping in, no creeping in of zeros. A few more examples showing quad, which is possible if we have got four of them sideways also and four of them in a rectangle form also, in a square form also. Now rectangle and square both are allowed to be present together, but if quad is possible, then it is not preferred for the user to take pairs. So if you are using three pairs from this, it will not be considered to be correct because it is not sufficiently minimal. And there is one more kind of group which is called octet. In an octet, there are 8 ones which are together, and an octet helps in removing three variables. Now, coming up in the next, how the groups help in removing variables and form the reduced expression. Now, coming up, so before that, it will be good if you practice this once all by yourself, okay?